By the name of God, most merciful, most kind, peace be upon you all, and God's blessing. Our subject of today is partial pivoting for 2 by 2 matrix. We are going to review the solved problem number 1 from the book of Professor Richard Burden, page 371. This is the reference, Richard Burden and Douglas Fair's numerical analysis. We'll move to the next slide. In example number 1, apply Gaussian elimination to the system. We have two equations. These equations are, first equation, 0.003 and 000 x1 plus 59.14 x2 equal 59.17. And the second equation is 5.291 x1 minus 6.130 x2 equals 46.78. Using 4-digit arithmetic with rounding and compare the results to the exact solution, x1 equal to 10 and x2 equal to 1. If we plug in x1 of 10 and x2 equal 1, we will get the right-hand side values. But we are going to try the technique that we have. Again, we are going to write the matrix A as augmented matrix, 2 by 2, 0.003000, then 5914, and this is the line, and the right-hand side is 59.17. For the second row, we have 5.291 from the second equation, followed by minus 6.130, and at the right side of the line, 46.78. We use this as a pivot, so in order to get 0 here, we will divide 5.291 over 0.003000, multiply by minus 1 of R1, and add to the second row. Why we use partial pivoting? We use partial pivoting because this value is nearly close to 0, so there is an error because we are dividing over a smaller value, and this value will become very big. We'll proceed. Minus 5.291 divided by 0003 by R1, add to R2, place the result in the R2. To this value, we call it M21, division of 2, A21 by A11. The value is minus 1763.6666. We are going to follow the requirement that the author told us to use the 4-digit arithmetics with rounding. So what are the 4 digits? 4 digits are 1763. Then due to the presence of the 6, this will cause the 3 to become 4. So for every operation, we are going to follow the requirement of 4-digit arithmetics with rounding. So the new element A21 will be 0.003, because this is the R1, multiplied by M21 after rounding, which is minus 1764, and we add to R2 to the A21 value, 5.291. So the new value is minus 0.001. Approximately, we can consider it as equal to 0. While for this element, which is the new value of A sub 2 is 59.14, which is a positive value, multiplied by minus 1764, added to the second row, which is minus 6.13, we are going to get this value, minus 104329.09. Again, we are going to make rounding for the 4 digits. Because of 2 is at the right side of 3, then there is no increase in the value of 3, and the final value of A22 will be minus 1043 followed by 2 zeros, because we have 6 digits, 1, 2, 3, 4, 5, 6. We'll move to the next slide then. We need to evaluate the new B sub 22. The value is minus 1764, which is M21, by this value in the R1, the right-hand side value, 59.17, and we add to 46.78. Again, we will multiply. We'll make rounding. This value, minus 1764 multiplied by 59.17, is equal to minus 104375.88. And this is a value 46.78. We are going to make rounding to 4 digits. So this is 7, it's more than 5. This will cause this value to become 4. So then this new value is minus 1044 zeros, like we are going to see, like this value, plus the 46.78, we come to the value of minus 104353.22. Again, we will make rounding. This is 5, so this will cause the 3 to become 4. The final value of B sub 22 is minus 104400. We are going to write the augmented matrix. R1, there is no change for R1, the first row. So this is again 0.003, followed by 59.14, again 59.17. This is rounded to 0, and this is a new value of A sub 22, which is minus 104300, and this is the new value of B sub 22, minus 104400. This will be multiplied by x2 equal to minus 104400. So if we are going to divide this value by the minus 1043, this will give us positive values. This is a minus and this is a minus, and we get x sub 2 equal to plus 1.0000095. Again, we'll make rounding for digits. This 0 will become 1. So the x2 is plus 1.001. We can see the difference. There is a big error because the exact value of x sub 1 is 10, while due to this division without row exchange, we get x2 equals to plus 1.001. We will make back substitution that we are going to see in the next slide. By using back substitution and using the estimated value of x2 equal to 1.001, we have here 0.003 multiplied by x1 plus 59.14 multiplied by x sub 2 equals 59.17. So in order to get x1, we can consider it as 59.17. x1 will be equal to 59.17 minus 59.14 multiplied by x2, which is 1.0001, all divided by 0.003. This value, 59.17 minus 59.14 multiplied by 1.001 equals to minus 0.02914, all divided by 0.003. For this first term, we have minus 0.002, and this, because of the 9, we will have this value as minus 0.030 divided by 0.003, so it is minus 10. Again, we will compare between the exact values. x1 is 10 and x2 is 1, while here, due to the division without row exchange, we have x1 equals minus 10 and the x2 is 1 in it. 1.001. In the next slide, we can see that the small error of 0.001 multiplied by 59.14 divided by 0.003 equal to 20,000. This is a small value exists in the first equation, and when we divide this, it is approximated to 20,000. This reunites the approximation to the actual x1 equal to 10. This is clearly contrived example, and the graph shown. This is a graph. This is the original first equation, second equation. By the real solution, we have 10, x1 equal to 10, and x2 equal to 1. While due to use this division, which is nearly the m2 20,000, this will lead us to another approximation of x1 equals to minus 10 and x2 equals 1.001, which is again completely different than the exact solution of 10.1. In order to remedy and to use this technique, which is called partial pivoting, we are going to make a new row exchange. First, we are going to check the maximum value of a sub 11 and a sub 21. Which one is bigger? We have 0.003 and the other one is 59.291. We are going to make it the absolute and choose the maximum. This is 5.291. Since this value a sub 21 is bigger than a sub 11, we are going to make swap or row exchange. The second equation will become the first equation, and the first row will move to the second row. Again, we are going to rewrite the new equations as 5.291 x1 minus 6.13 x2 equals to 46.78. And the second equation will be 0.0030 x1 plus 59.14 multiplied by x2 equals 59.17. In order to get the m sub to 1, we need this to become 0, and this is our new pivot. We are going to divide 0.003 over 5.291 multiplied by minus 1. We get minus 0.000567. We'll move to the next slide. Again, this is augmented matrix. M sub to 1 is minus 0.000567. What is the new value of A sub to 1? The new value of A sub to 1 is minus. We will write it as, this is the last slide. The R1 value is, there is no change. This is the augmented matrix, 59.21 minus 61.3 equals 46.78, and this is A sub to 1, 0. This is 59.143 multiplied by x2 equal to 59.143. In order to get this x2 value, we'll divide 59.143 by 59.143. So the value is equal to plus 1. This is the value of x2. We are going to make back substitution to the equation, first equation. The value of x1 equals to 46.78 minus, multiplied by minus again, 6.13 x2 divided by 5.291. We are going to see x1 equals 46.78 plus, because minus by minus is plus 61.13 multiplied by the value of x2, which is plus 1. This value 46.78 plus 6.13 will give us 52.91 divided by 5.291 will give us x1 equals to 10, which is the same as the exact solution of x1 value equals to 10, and x2 as well is equal to x2 real. This is the what is called partial pivoting. We make row exchange because we find that the value of a sub to 1 is bigger than the value of a11, and the division of the old a sub to 1 over a11 will create an error and change dramatically the values of x1 and x2. Thanks a lot, and see you in the next video for another kind of pivoting. Goodbye and take care. 5.67 divided by 0.14, we get 59.143, while b sub to 1, the new value, will be minus 0.000567 multiplied by 46.78, and we add the result to 59.17. We get 59.143. This value is multiplied by x2, and this value is the right hand side value. We'll move to the next slide. This is the last slide, and this is the augmented matrix. 5.291 minus 6.13, and this is the dotted line. 46.78, and this is the new value of a sub to 1, and this is 59.143, and the right hand side is 59.143. We can get the value of x sub 2, which is equal to 59.143 divided by 59.143 will give us plus 1. We make back substitution to the first equation. In the first equation, we have 5.291 multiplied by x1 equals 46.78, and we will move this one to the right hand side by changing the sign. It will become 6.13. So we can write that x1 equal 46.78 plus 6.13 multiplied by x2, which is plus 1, all divided by 5.291. This value is 52.91 divided by 5.291 equals to 10, which is the same value of x1 for the exact solution, while the x2, due to the approximation, equals to plus 1, which is the same as x2 value for the exact solution. So by row exchange, we use the first type, which is partial pivoting. We have selected the maximum value or the maximum absolute value of a sub 1 and a sub to 1, and we have decided that the a sub to 1 being bigger than a sub 1, so we are going to make row exchange, and we shifted the second equation to become the first equation, and we have proceeded to evaluate the value of x1 and x2. In the next video, by God will, we are going to introduce to another kind of pivoting. Thanks a lot. Goodbye and take care. God bless you all.